The sky looks great. That's where the sun has just set over there, and I can just see Polaris up there, which you probably can't see with this camera, but Sadr is just there. So I'm going to go onto the Sadr region tonight and see if we can do any imaging. The scope is rigged and it's cooling down at the moment. I can see Polaris, so I think I might be able to get my polar alignment done. This is the polar alignment routine in SharpCap. So I've just gone into the routine and it now prompts me to rotate the right extension, which I've just done. And then it shows me that the polar alignment is currently poor. You adjust your azimuth so that it is properly aligned. So I'm adjusting the scope and it says I have to adjust it on the left, so that's what I'm doing at the moment, and it's pulling the scope round. Now it's very easy to overshoot whilst you're doing this and end up on the wrong side, so you just have to do really small adjustments until you get it exactly where you need it. After I'd adjusted the azimuth, I then moved on to the latitude bolts and slowly but surely adjusted those until the polar alignment said good. Good is actually perfectly fine for guiding, and I have no problem with just leaving it at good. It is possible to tweak it to get it to when it says excellent, but I find the benefits of doing that are kind of negligible for my needs, and my guiding is pretty good when the polar alignment routine just says good. Open PHD2 and connect all of your gear, and then in Nina connect your camera, and then connect your focuser, and then connect your telescope as well. Then you need to go to the framing wizard, and I'm wanting to be looking at the Sadr region, and you type in Sadr and it comes up with the right ascension and declination, and then you can click load image. After this you adjust it until you've got the framing which you hope to achieve for this imaging session. Then we go back into the mount and we unpark the mount, and then we go back into the framing wizard and click on slew and center. Then the mount will slew to where it thinks the Sadr region is, and in the meantime I'm now starting the cooling on the camera. When the mount has reached the Sadr region, it then takes a short exposure and plate solves that exposure to see if it's pointed at the right part of space, according to the right ascension and declination coordinates which were populated in the framing wizard. It will then calculate how far away it is and then re-slew the mount in order to frame up the exact area of space which we have specified in the framing wizard. It will do this a few times until the framing is absolutely spot on within a few pixels. I then go over to the imaging tab, and after it has initialized, I'm now going to run an autofocus sequence. The focus was actually quite close because it was able to plate solve the images, but that would have been from the previous imaging session. So I'm now running an autofocus routine on the area of sky which we will be imaging during this session. After the focusing, I then went into the sequencer and I built this sequence that you see here. So I wanted to take 85 lights of 180 seconds and dither every 2 frames, so every other frame. I wanted it to start guiding at the beginning of the session and also refocus on the start as well, and also whenever there was an HFR increase of 10%. So I could now click go on the sequence, and then the autofocus will start and the sequence can then begin. I then let the sequence run overnight until it had finished, and then Nina will have parked the mount and also warmed the camera, ready for me to come downstairs in the morning and put it all to bed. I only managed one night of imaging on this region and it was quite cloudy, so the image was a little bit washed out, but I did try something different to improve the image, which was really interesting. Graxpert. Have you tried Graxpert? It's extraordinary. This is the stacked image with a bit of processing in Pixinsight, and I'm now at the point where I want to make Sadr, because there was some cloud and Sadr is so incredibly bright, I want to make it less powerful, and there's also a bit of a light pollution gradient as well. This is the original image as I loaded it into Graxpert, and then if we look at the background it removed, we've got rid of all of this and a bit of that light pollution as well, and some red there as well. And then the processed version is this. That's pretty amazing. It's just wow. It's really good. Really good. So original is there, and then processed is there. It's flatter. The star, it kind of has a bit of a halo-y effect going on, but I quite like that. But it's a lot better. It's still very noisy, but I can work on improving that noise. I think that's really good. So Graxpert, this really is amazing. What a brilliant tool. Absolutely brilliant tool. And I strongly recommend you check it out. This is the AI version, which I'm not sure if they've released the official release for this yet with the AI. I'm still using the version where you download the files from GitHub, and it seems to work amazingly well. So yeah, go and check it out. Really, really amazing program, and it's free. This was the final image. Can't believe that I've gone from something that kind of began like that to something that looks like that. Without shadow of a doubt, things which have helped me with this image are Graxpert, so the gradient extractor. That's absolutely amazing. And the other things which have helped me are the RC Astro noise exterminator, absolutely brilliant piece of software, and the RC Astro blur exterminator as well, to deconvolute the stars and sharpen the image as well. It's just really, really good. I'll show you my first process, which I did a couple of weeks ago, and it's nowhere near as good. This was my first go at processing this data, and this was before I also learned about the bias frames as well, so it didn't stack very well, and you can actually see in this particular image that there are dust motes, circles in the corners and so on. I've had to crop in quite a lot to get rid of all of that, but compare this to that. We've now got these unbelievable tools. This is less than an hour and a half's data because there was so much cloud that night. Absolutely brilliant.